Let's now create two public methods, createTopics and checkTopicsCreated in kafkaadmin client class. We will start with createTopics method. In this method, let's first create a local variable, createTopicsResult, and then use retry template, execute method to call a new method doCreateTopics. The return type of doCreateTopics method will be createTopicsResult. We will implement this new doCreateTopics method shortly. Let's now create a try catch block with throwable for retry template execute method, and throw an exception in case retry template failed with a throwable. Here, instead of runtime exception, let's create a specific class called Kafka client exception that extends runtime exception. We will create different classes for each type of exception so that we can distinguish different exceptions throughout the system. I will also call checkTopicsCreated method at the end of the createTopics method, so that we do a double check to be sure topics are created. Now in the doCreateTopics method, let's get the topic names to create and write an info log to mention that number of topics creating. Then we will convert the list of topic names to string and then map it to a new topic class. To create a new topic object, we will pass topic name as parameter, as well as number of partitions and replication factor by reading them from Kafka config data object. In the end, we will collect this map to a list and then assign to a variable called Kafka topics. Now we are ready to call kafkaadmin client's createTopics methods, where we will pass the list of new topics objects we created here. Next, we will create a private method called getTopics. It will return a collection of topic listings. Here, let's first create a local variable topics, and then call retry template execute method to call a new method doGetTopics. Again, we will implement this method shortly. Let's surround this execute method with a try catch block and throw a Kafka client exception in case an error occurred during retry template execution. Then we will return the topics from this method. Now in doGetTopics methods, let's first write a bit of logging, mentioning reading Kafka topic and in which attempt we are. Then we will call admin client's list topics, and then listings method, which will return us the collection of topic listings. And then we will go over all the topics and just write a debug message to say that topic with the name is ready. Finally, we will return a collection of topic listings from this method. By the way, this catch statement should be throwable again, as was in the createTopics method. And let's pass the throwable as a second parameter to the Kafka client exception in both createTopics and getTopics methods. Let's finally implement checkTopicsCreated methods, where we will first call the getTopics method, which will return a collection of topic listings. And then we will create some local variables. First, create an integer retry count starting with 1. Then let's read the retry config data to get max attempts, multiplier, and sleep time millisecond variables. Finally, we will go over all the topic names to create, and check if the topic is created or not. With method isTopic where we will create it shortly again. Then inside the while loop, we will check if we reach the max retry, and again we will create a new method for this one shortly. Then sleep for the configured amount of time. Then increase the sleep time by multiplier. And then read the topics from getTopics method again. Here it might take some time to see the created topics when we call the getTopics method because the createTopics is an asynchronous operation. That's why we added a custom retry logic on top of the retry template here. And we try to check until a maximum retry time and then exponentially increase the sleep time until we get the topics using the getTopics method. Let's now implement these three methods: isTopic check max retry, and sleep. In the isTopic method, if the topic collection is null, we will return false. Otherwise, we will convert this to a string and search for a match for the topic name. In check max retry, we will just check if current retry number is greater than max retry. And in that case, we will throw a Kafka client exception. And finally, in the sleep method, we will simply sleep for the configured amount of time. Alright, at this point, I also want to add a check schema registry method to be able to check if schema registry is up and running. In previous methods, we checked if Kafka is up and running and the topics that we want to work on are created. But we may also want to check if schema registry is up and running because we will run everything, including schema registry, Kafka, and our services in the same compose file. We don't want to fail at startup because schema registry is unreachable. So we will add a check for schema registry also here. To do that, we need to make a REST call to the schema registry endpoint. Let's now implement the same logic as we did in the check topics created method. Use the max retry, multiplier, and sleep time millisecond configuration variables. Then create an infinite while loop. Check the max retry, and then sleep for the configured amount of time. And finally, increase the sleep exponentially. Now, to make a REST call, we need a new dependency in our module. I want to use the web client from Spring Boot, and to be able to use it, we need to add Spring Boot Starter Web Flux dependency. Web client is the non-blocking, reactive client to perform HTTP requests, and it provides a Fluent API. To create a web client, you can use the web client create method or use web client builder build method. I will choose web client builder build option as it is the most advanced option and it will allow to customize the web client better. And instead of creating the web client in my code each time, I want to create a Spring Bean and reuse it each time when I need a web client. How can I do that? I need to create a configuration class and return a web client object in a method that is marked with bean annotation. This way, Spring will create a web client bean at runtime so that I can inject and use it in my code. So I will create a web client configuration in config package to configure the web client. As you see, I mark this class with configuration annotation. Then I create a method to return web client using web client builder object. And as you see, I mark the method with bean annotation here. I don't add any specific customization to these web clients. However, in the coming lectures, when implementing the query service, you will create and use a more customized web client. So this class is marked with configuration annotation, and when I create a method here with bean annotation, Spring will create a bean for this method at runtime. And this bean will have the type of the returned object of this method. As you see, the return type is web client. So Spring will create a web client object so that I can use and inject it anywhere that I want to use a web client to make a REST call. Now I can return to the kafkaadmin client class and then we'll inject the web client bean into kafkaadmin client using constructor injection. So I define a final web client field and set it in the constructor so that Spring will inject this bean at runtime for me. Alright, let's now create a new private method, getSchemaRegistryStatus, which will return HTTP status object. We will make a REST call here and return the HTTP status to check the status of the schema registry. As a HTTP method, we will use get. For URL, we will pass the schema registry URL from the configuration variable, and then we will call the exchange method. Then we will map the response to a client response status code object. And finally, block the operation to be able to get the results synchronously from schema registry. And in case there is an error in the REST call, I will catch it and return service unavailable status code. And finally, in the while loop, I will call the getSchemaRegistryStatus method and check if we have a successful HTTP status result. So I will wait until schema registry is up and running or the retry count reaches to the maximum amount. Alright, we will use these three methods, create topics, check topics created, and check schema registry to be sure that Kafka and schema registry is up and running. And also the topics that we want to work on are created. We will add more checks on the Docker Compose in the coming lectures. But here also I wanted to add some programmatic checks to be sure that our application will start and run correctly. Because as I said, when we run everything in a single Compose file, if Kafka or schema registry or any other dependencies are not running, our application can fail at startup and will not continue to work as expected. Great, we have now finished the Kafka admin module. Let's start to implement Kafka Producer in the next lecture.